Hi everyone, welcome to this video where we're going to start looking at functions. So first of all, what is a function? Well, functions are a very specific kind of relation. Okay, so here's our definition. A function is any relation where for any x value in the domain of the relation, there is only one corresponding y value. Or in other words, any x value in the domain of your relation is not allowed to have more than one associated y value. Okay, so let's have a look at a few examples just to sort of see what the hell we're talking about here. All right, so the question is, which of the following relations would be a function, and how can you tell? Okay, so first of all, if your functions are written, or if your relations are written in terms of this sort of set notation style, it might be, first of all, handy to consider what the domain of the relation would be. So let's look at this first one here. Okay, so we've got a domain of, well, the domain is just the x values of your relation. So we're going to have -3, -1, -6, and 1. Okay, then you need to ask yourself the question, if I take each x value in the domain individually, is there more than one corresponding y value for that x value? If the answer is no, then your relation is a function. So you look at -3. Okay, the only corresponding y value for an x value of -3 is this -4 here. There's no other points in your relation that have an x value of -3. Okay, there's only one point with that particular x value. Same thing for an x value of -1. There's only one point where the x value is -1. Okay, and you can do that for each of these x values, excuse me, in the domain. And for each of these x values, there's only one point corresponding to that x value. Okay, there's one point for -3, there's one point for -1, there's one point for -6, and there's one point for 1. There are only 4 x values in this domain corresponding to the 4 points in our relation. Therefore, this is a function. Okay. Right, this second one over here. So you may recognize this relation, okay, this relationship between x and y, x squared plus y squared equals 1. You should be able to recognize that that is a circle. Okay, it's a circle with a center at 0, 0, and which has a radius of 1. Okay, so let's think about what the domain of this relation would be. Well, the domain is just the set of x values for which your relation is drawn or graphed. Okay, so if you look at the domain for this, your graph goes from -1 to +1. Okay, so the domain of this function is -1 to 1 inclusive. Then you've got to ask yourself the question, if I just look at each x value in this domain individually, is there only one corresponding y value? Or another way to ask the question, if I take an x value, is there only one point that corresponds to that x value? Okay, so let me change colors here, make it a bit easier to see what I'm doing. Let's consider an x value of 0. Okay, so if I consider an x value of 0, that means we're talking about, talking about the x value at this point here. Okay, now if I look at my graph, there are 2 points that have an x value of 0. There's this point up here and this point down here. Okay, so that means there are 2 y values for one x value. If that happens, your relation is not a function. Okay, so this is not a function, simply because if I take an x value, I can find 2 points that correspond to that x value. For something to be a function, that's not allowed to happen. Okay, so let's look at this third one down here. Again, you might recognize this equation here is just the equation for a straight line that goes through a y-intercept of 1. Okay, so that's going to look something like this. Okay, that's 1, that's -1, and that line goes on forever in both directions. Okay, so first of all, what's the domain of this relation? Well, you should be able to see it's all real numbers, okay, because you can put any number you like for x and it will give you an answer. Let's try and test if this is a function. Okay, so if I pick an x value and I try and find the point on the graph that has that x value, is there only one point that does that? Okay, so if I pick an x value of, say, I don't know, 10, that might be up here somewhere. Is there only one point that corresponds to that x value? Yes. Okay, that would be the point if I extend my graph here. There's no other point that has an x value of 10. All right, or if I choose -2, that might be here. Okay, is there only one point that corresponds to an x value of -2? Yes. There's no other points, okay? And because you can do that for any x value you choose, that means that this relation is a function. So yes, that's a function. Okay? All right, last example here. Okay, we've got a relation given in terms of just some points. It doesn't have an equation associated with it or a rule. Okay, but if you look at the domain of the relation, okay, the domain is 1 and 2. Okay, there's 1 here, 1 which you just write once, and a 2 which you also just write once. So the domain is 1 and 2. So what you do is you take each x value and you say, okay, is there only one point that has that x value? Well, in this case, no. Okay, we have a point 1, 2, but we also have the point 1, 3. Okay, each of those points has the same x value, therefore it is not a function. For something to be a function, each particular x value in your domain is only allowed to have one corresponding y value. Okay, in fact, if you were to graph this, if you were to plot those points in on your Cartesian plane, you would get something that looks roughly like this. So 1, 2 is here, 1, 3 might be here, 2, 2 would be here, and 2, 3 would be here. Okay? So if you pick an x value of 1, corresponding to there, you can see there's 2 points that have that x value, that point and that point. Okay, so automatically that means it is not a function. All right? So that's the definition of a function. That's what a function is. That's how you can tell whether or not something's a function, okay? And we're going to look at an easier way to sort of tell if you've got the graph of the function. That's using this thing called the vertical line test, okay? So what is the vertical line test? If a vertical line can be drawn anywhere on the graph and it only ever intersects the graph a maximum of once, then the relation is a function. Okay, so as an example, here we've got the graph of y equals x plus 1, which I'll sketch in. Okay, recall that this is just a straight line, the gradient of 1 that goes through an y-intercept of 1. So that would look something like this. Okay, that'd be 1, that'd be -1. All right. So what we're going to do here is use the vertical line test. What we're going to pretend is that there's a vertical line that we can draw anywhere we choose on this graph. Okay, anywhere you like. So let's draw a vertical line here. Does it intersect the graph only once? Yes. What about over here? Does it intersect the graph only once? Yes. Okay, and you can imagine sweeping this line across, starting from -infinity or the beginning of your domain all the way across to the end of your domain, okay? And if this vertical line only ever touches your graph once at each position that this vertical line could be in, that means your relation is a function, okay? This y equals x plus 1, it's a function because it passes this vertical line test. This vertical line you can put anywhere. It will only ever intersect your graph a maximum of 1 time. Okay? So this is a function. Cool. All right, what about the sort of reverse of this statement? So, sorry, a bit of lag. There we go. Okay, alternatively, If you can draw a vertical line somewhere on your graph so it intersects the graph more than once, the relation is not a function. Okay, so here's our example that you should recognize is the equation of a circle that is centered at 0, 0 and has a radius of 1. So it's going to look something like this. 1, negative, that's positive 1, negative 1, negative 1. Okay, cool. So what we're going to do is start sweeping across a vertical line. Okay, so we'll start our vertical line here, because that's the start of our domain. Is it intersecting the graph once, more than once? Well, it's only once. It's only intersecting our graph right here. But if we start sweeping this line across, okay, anywhere in between -1 and 1, your vertical line will intersect the graph at 2 spots. When that happens, that means this relation is not a function, okay? It fails the vertical line test because it intersects your graph more than once, okay? Functions are not allowed to have this vertical line intersect their graph more than once at any given position, okay? Cool, so that's it. That's it for this video, okay? We just looked at what a function is, how you can test whether or not something's a function using this vertical line test, okay? And just remember, for a function, an x value is not allowed to have more than one y value. Equivalently, if you pick an x value, that x value can only exist at one point on your graph, not at multiple points. Okay, there we go. So we'll stop there, and I'll see you in the next video.